Hey everyone, so I thought I'd go over a little of a dyno run in the study with Come Workshop. So got the car on the dyno, got the Motiv in, all hooked up, and I'm going to go through a run. So make sure you guys have seen this before. I'm going to hook up, activate the throttle, confirm it's all working okay, and go through a auto test, test 1. So that's test 1, let's do test 2. Simon, I know the feeling, but I'm going to go through the results in a minute, and hopefully you'll get a bit more of an insight into what you're looking at. So bear with me. So that's 3 tests done, and I can right click here and get a data, what's that all about? Data printout, and down the bottom here I think you can set it, and it allows you to check all the points. So the dyno will record data points when it's taking obviously the data of the run. So I think I've got this set to 32 points, which is plotting this graph up here. So what you're looking at on this graph at the moment is RPM over time. If you want to look at kV over time, and click that, and then it gives me a different graph. If you want to see torque power out versus RPM, that's something different. And if you then want to look at torque and power versus kV, you can do that as well. So lots of variables that you can look over. And so this is all the data down the bottom from each point. And so when you're doing a dyno run, you can select, because I've got this on auto test mode, so it effectively does it for me and it's consistent. So on the bottom here you can set where the auto start kicks in. So I set it so it's running at 40% in terms of on the throttle, because I don't think you would ever drop below 40% on track on your throttle, and then it hits full beans and holds it for 6 seconds. And that happens after 5-second runtime. So that's the setup, and again I can adjust that as much as little as I want. So I can have it starting at 60%, 80%, 95%, whatever. So what you can then look at when you're coming over to here is let me just OK and come out of that. On the right hand side, we're then able to look at all the different points. So you've got the voltage at when it starts the readout and where the voltage drops off to. So if we just take voltage to start with, so it's at 3.92 when it kicks in, and then it has a slight drop off, and then it balances itself back out. So it goes hard and fast to start with, then a massive rebound, and then starts to plateau out. The current draw at the point of where you hit full beans, 48 amps I guess that is, and then you can see down the right there, so this part here, you can see how the drop off then continues as the car is then up to speed. So when the car is doing flat out, it actually doesn't pull any amps at all, because the car's obviously working and it's not taking much effort to get it going. But if you look at the point between 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, probably 18, 19 points before it starts to plateau out. Now, I think this is about 30 points over a 5-second period. So you work out whatever that is. So what's that? 5 seconds divided by, well, I'm not going to go into that because I'm not that great at maths, but you can work out how many points. So 13 intervals, you're from full beans. It's then going back to a plateau. So every time you hit full throttle from 50%, you're taking a hefty whack out, hefty run out of your lipo when you hit full beans. So that's quite interesting. If we go over to the power out, you can see there's quite a significant drop off as well, and probably matches the volts really, or the amps. Yeah, it matches the amps. So that's that. Torque wise, down the left hand side, how that's changing. Again, this is not really stuff that I know, so I'm just showing you what it can do really. Down the left hand side, looking at the RPM. Obviously the RPM starts measuring it from the point it kicks in, and obviously this is the RPM graph down at the bottom here, and so as it kicks in, it goes up to 4,573. Now, if you stick a motor on a motorizer, depending on what motor you've got, I've had 11,500 RPM, and I've had up to 14,500 RPM with an Orion. And this is down at 4,500, so you can see it's very different. So the load obviously is very different on the motor, and therefore the RPM is very different. So then when I've pulled up here, I've got the graph which shows us all the data, and so this is on it's on 3 exact runs. So one guy that we all love and hate, Darren Russell, was going on about how inconsistent this bit of technology is. Well, if we look at the run, so this is 3 runs identical. So we got 4,573, 4,582, 4,573 in RPM. Well, I mean that's 9 RPM out over 4,500. So I think that's pretty darn accurate. Spool time, well, that's 0.1 of a second within accuracy. The voltage, again, this is just what it is. So this is reading it. I don't know why that would have dropped off. Again, 3 runs. Now the voltage is going to be going off, so I'm tipping that's why that's happened. But I'd done about 8 or 9 runs before this, so that's why that voltage would have changed, I would have thought. No, because that's reading it at 2 different points, isn't it? Because the RPM, the voltage was being read at 1,400, and the voltage was then being read at 4,500 RPM, so it's 3.7. So there's 2 points there, so that is actually accurate. RPM and current, torque, power in consistent, power out fairly consistent. Efficiency, obviously it's becoming more or less efficient as time goes on because it's getting hotter. and these are the temps down the right hand side there. I've got to get a temp cable for it. So that's pretty much what it does, and that is the Motiv, and I am about to have a fiddle around with that. So I guess that what I'm looking for here is I'm looking for more RPM. I'm guessing I'm looking for current draw to be less, I'm guessing. The power out I want to be more, I'm guessing. Temp we can't see, but then using the graph I'm able to compare motor to motor, which is what I'll do going forwards. To get the speed, it gives me speed down the left hand side here, kV, RPM and miles per hour, so I can actually see that I can change that. And to get the miles per hour, the reason why that can be accurate is because the chassis dyno allows me to put in the tyre size. If you guys have got any questions, I know there's only a few of you on, but if you've got any questions, feel free to ask. And what I'll do now is I will put a brand new battery on. So let me take that battery out because I've done a few runs. And take that out, put a new LiPo in. Put that in there. Plug that in. And I calibrate the ESC to the laptop. So that's all plugged in again. So what I'll do now is come back over here. I'll take the data grid away, and what I'll do is I will get rid of the last two. So I will delete test run 2. No, I won't. I'll go the other way. Yeah, and I'll do that. Delete test run 2, and I'll delete test run 3. So this is the first test run just a second ago. Now I've got a fresh battery in. Activate the throttle. Just check that that's working. Yeah, that's working. And they'll do exactly the same test. And so we'll see. You saw that did 3 runs on a bit of a flat battery, and I'm talking like 12 runs. I think probably done 12 runs. And now I'll do a run with a fresh battery. And let's see what the implications are of that. Sorry about the vibrations on my hand. As you can see, it kind of goes a bit nuts. So now I can go to the preview, pull that up. So on the second run, so the third run is non-existent, nothing to see there. So we found a little bit more RPM. Voltage is pretty much the same. Current, nuts and bolts the same. Torque is slightly, that's been read at a slightly lesser RPM. And because the battery is new, it's become slightly more efficient. So I'm guessing that's why, because it's got more amps going in. If we go back to display the grid, so let me just take that one away. Take print preview. delete test 3. So what am I trying to do here? I'm going to use. So this is. Let me just now go to print preview. Back to that. No one got any questions? I'm just happy watching. So that's that. So I'll tell you what I'll do now then. I will get rid of test 1. And what I'll do is I will turn the timing up on the motor. Turn my lamp on. The timing I've got it at the moment is 44. So I'm going to go down. I'm going to go down 4 degrees. Sorry if you can't see anything at the moment. I'm just keeping hold of the camera as well as turning down the timing. So oops. So timing just gone down 4 degrees. Make sure that's still working. Let's go for another test run. Well, so we can see on the chart at the bottom here, this RPM chart, I've turned it down 4 degrees, but I've got a heck of a lot more punch, and by the looks of it, I've lost nothing in RPM. Nothing in RPM at all. So I've lost, well, what's that, 30 RPM. Current draw is less. Torque has gone up. So I'll be looking at the top one here. It's gone from 8.2 to 9.62. Power out has gone up 3.6. And the efficiency has gone down ever so slightly. Again, I don't really know what that efficiency number is, but what we do know is that that motor has become has got no less speed for it, but the current's gone down and the torque has gone up. And if we look at the profile on the chart, we are able to see, you can see down the bottom here that's gone up. The punch has gone up and the RPM has pretty much stayed the same. So what I might do now is go up a tooth on the pinion. And see if I can get so that was 32, I need a 33. 33. There we are. There's a 33. So pop that on there. You have to bear with me 1 second. Can't believe nobody's got any questions. I suppose it's because you know I haven't got any answers. Okay, that's that changed. So I've now gone up a tooth in the rollout, and at this point I'm now going to do another run. Here goes. So, let's have a look on print preview, see what's happened there. So what's happened is that so the first one was with the lesser timing, and the number 2 was with 44 degrees, and then I went down 4 degrees to 40 for the third one and the first one. So the second one's at 44 degrees, first and third are at 40 degrees. The first one's at the 32 pinion, I can't remember what the rollout is, and the third one is with 33 pinion on. Current draw has now gone up significantly, 51.95 from 46.86. The torque is still more than it was at 44 timing. Power out much the same, but we've seen a drop off in efficiency. Now what that means on the track, I have no idea. But if we go back to the original chart, so if I take away, so that what do I want to do here? So I want to show you. So the first one had no punch, but more top end. So the blue line here is the one that had more punch, and the yellow line, so the yellow line was the one where it was at 44 degrees timing with 32 pinion. The blue line was the one at 40 degrees timing, but with the 32 pinion as well. And the line that you can't see, which is the run I've just done, is the one that tracks the blue line to start with and then tracks the orange line at the end. So basically what I've just done is I've got the best of both worlds, because if I take if I delete test 1, the blue line, you can see that I've got the best of both worlds. I've got the punch and I've got the rollout, punch and the RPM. So that's what the information could do. But you can see on the graph at the top here, we've got two very different pulls in voltage, current. I've got one that's putting more current here than the one before, 10.7 compared to 6.1. So everyone that talks about this 6 amp pull, there it is there, the bottom one. So arguably should be back to what I was before. Who knows? But all it does is it just gives me a bit of an insight into what I want to have a fiddle around at, and interesting stuff really. And that's pretty much the tip of the iceberg, because obviously it allows me to also have a fiddle around with speedo settings and other various parts of the setup of the car. So there we are. I hope that's been useful, and look forward to seeing you trackside sometime soon. Toodaloo.